Let's review some circle properties. Let's start off by naming some things. Remember, if you want to name the circle itself, you literally just do a cute little circle with a dot in it. Circle J. Radius is the length from the center of the circle to a point on the circle. So see, there are actually several drawn in this figure. I drew to save some time. And the radius, since it's actually segments, it's going to be a bar over it, like JI, JB. And remember, the order doesn't matter as long as it's a bar over it. JC reminds me of an old DC Talk song back from the early 90s. Anyway, so J and any of those four would be a radius. Now, a chord is a section of the circle where it's a segment, but the ends are on the circle itself. See how over here, E and F, it's a segment and it ends on the circle? So you've got EF, same thing with a bar. You even have this one. It stretches across the center of the circle, so technically it's a diameter, and by definition the diameter is the longest chord, because if you start this way and go toward the center, then it's going to start getting smaller. Last but not least, technically this over here is a chord as long as you put a bar over it. And I know some of you are saying, well, it's attached to a line. Well, this segment is a chord. Now, by definition, a line that cuts through a circle is called a secant. So secants can never have bars on them. It always has to have the line over it. Same thing, GH, HG, works either way. Last but not least, tangent comes from the Latin word tangere, means to touch. And notice how this line touches the circle right there. So the tangent, you need to use any two of those letters. You could do AC, CD, AD. And technically tangents can be segments or lines. So you could do both. It doesn't matter, just personal preference. If you wanted, you could keep to yourself, always use the bars unless secant lines, and that way you could never go wrong unless you chose the wrong letters. But anyway, so then we did central angles. Now, central angles is if it includes the center of the circle. Play on words there. And the central angle is equal to the arc out here. So if I wanted to find QR, it would just be 60. Now, what about if I wanted to find PQ? This. Well, whenever it says or it tells you a diameter, I'll always darken it. So that way, if you ever want to do something with it, you remember, oh yeah, I know what that is. Because if this is 60, and that's the diameter, which cuts the circle in half, 360 divided by 2, 180. So that means there's 180 on the left, 180 on the right. So if this is 60, 180 minus 60, 120. All right, let's even say, I'll make some vertical angles there. If I know my circle's lopsided, just don't pay attention to it. So if this is 60, that's 60. So let's just put an E down here. So if I wanted PE, it would also be 60. Now let's just throw in, I'll do an A so that was pair. Let's throw in a 30 right here. Of course, AR, 30. Now, notice how if I wanted QA, always do the shortest direction. I know you're like, ooh, QA. No, no, no. You're not going for a stroll. Shortest distance. QA, 60 and 30, 9. Now, if you wanted to find, that's all of these. Minor arcs, remember, less than 90. I'm sorry, 180. Major arcs greater than 180. So you can add them together. Let's say you did want to go all the way around. Like, let's say EQR. Well, you're going to start at E, and you have to go through Q. So Q has to be second. So that means it's like, whoop, there's the R. So I got to go this way. So EQR is from here to there. Well, you've got 180 and 60, 240. Now let's say they wanted, we'll do one more, APR. In other words, APR, everything but the 30. So if the whole thing is 360, 360 minus 30, 330. So that's central angles. Well, let's do some chord properties. Now, the thing about chords, if this segment, in other words, let's say DC is 10 and EG is 10, that this, and if you draw the center, a line from the center to the chord, it's always going to be at a right angle. And if the chords or the lengths of the segments are the same, then that means those chords equal. So that would mean EG equals DC. But it also means that this distance equals. So AB equals AF. So if they gave you something like DC is 14, EG is 14, AB is 6, find AF. So 14, 14, 6, 6. They could also give you something like, let's say, DC is 12. And they, of course, they would have to give you AB equals AF. They give you this, and they give you DC is 12. Find EF. Well, if this is 12, that's 12. And besides being perpendicular, it always cuts it in half. So hence, it's technically called the perpendicular bisector. So 6. So if this is 6, that's 6, so forth. Now, last but not least, I know you're thinking, oh, there's a right angle. What about if I draw the radius there? Of course, they can give you some with Pythagorean theorem. Like if I told you, find AF if FG is 8 and AG is 10. Well, put in your figures, so 10, 8, x, Pythagorean theorem, 10 is the one by itself. X squared plus 8 squared equals 10 squared. X squared plus 64 equals 100. 36, square root, 6. Notice how that one came out even, so it was actually a 3, 4, 5 Pythagorean triple. I gave you a nice one on purpose. And just a side note, if you were to extend that and make an E, back before when, let's say, if I said DC is 100, and I extended that, the arc is also cut in half. So if I told you DC is 100, 50 and 50. Not many of those, but wanted to give it to you while it was on my brain. Now, tangents. Tangents, remember, touch the circle in one spot. And if you draw the radius to the tangent, it's called point of tangency. It's going to be at a right angle. Now, that's terrible, but it'll be all right. So, let's say if this is 5, this is 13, and we wanted to find this length up here. Yes, Pythagorean theorem. There's your right angle, so 13 is by itself. 5 squared plus x squared equals 13 squared. Hopefully to some of you these numbers are ringing true. I did it on purpose. Yes, it's another triple. Subtract the 25, so x squared is 144. X is 12. And here's another fun fact. If you have one point that's outside the circle, and you draw where it has two tangents, a tangent on, doesn't matter as long as you have the point outside and it's tangent to the spot or the circle in two different spots. If this is 12, that's 12. And then, of course, once you find that's 13, 5 and 5. And like, for instance, if sometimes they like to give you something like this. If I gave you 2, 4, and 5, you've got two tangents, so 5 and 5. 4 and 4, 2 and 2, and if they wanted the perimeter, you could just add it up. 6 plus 9 plus 7, 22. Now let's move to inscribed angles. Inscribed angles, in other words, it's when the angle's vertex is on the circle itself. So remember, central angles, it was the same. Inscribed, it's always going to be half. So if the angle is 75, obviously not to scale, I know, 75, then the arc would be 150. Just like if I gave you the arc was 120, the inscribed angle, 60. They could, let's say, want you to find this. Let's say this is 100 and this is 40. I know you're like, wait, they didn't give me that, so I could divide by 2. Well, remember the entire circle is 360. Well, if they give you 140, that means there are 220 left. And then half of 220, 110. Now, another neat thing about inscribed angles is see how I put a 1 there? How angle 1 is an inscribed angle of this arc. Well, notice how if I draw one from this side too, let's put a 3 there. Angle 3 also is an inscribed angle of the same arc. So guess what you know about 1 and 3? Angle 1 and 3 have to equal. So if this arc is 40, that means 1 and 2 are both 20. Another thing about inscribed angles is if you have a quadrilateral inscribed in a circle. Wow, that's terrible. Well, you know what, it's supposed to be pretty. Let's say this is 80. So the opposite angles of any quadrilateral inscribed in a circle will add up to 180. So 180 minus 80, 100. If this side's 30, 150. Now, if they just give you one set, you can't find the other unless it's a square. But any rectangle, the opposites will always add up to 180. Now one more. And notice how this one's a little sneaky. Let's say that's 50. If this is the diameter, remember how many degrees have to be here? Yep, 180. So if this is 50, then this is 130 divided by 2, 65. Well, hope this was of help to you. There's all sorts of things with circles we haven't got to yet, but this is a good, maybe 2/3 of it. Holler if you need me.